Okay, so I decided to take this Arduino Nano, this new board, tiny board, to the next level, and that is by basically trying to do some multitasking, because previously I've been doing all that I've done was more like sequential, and basically I had to make use of certain function called delay time. So suppose I want to turn on and off two LEDs. The first LED would be turned on for a certain amount of time before I can actually go to switching the second LED to a certain amount of time. So I have to spend certain time in delay, where basically the microcontroller is busy doing nothing. And because this microcontroller does not have an operating system, so multitasking have to be implemented by hand. And in this case, what I've done for multitasking is, so I wanted to actually push the limit of Arduino and do more than one thing. Run the LEDs in a multitask fashion, turning them on and off, as well as running the buzzer, and also being able to control the servo motor through the potentiometer. So we have a potentiometer here that can vary basically the voltage, and we want to read it on certain pin, analog pin on the nano board, and try to use that value to actually move the servo to a certain angle, a certain position. So how is that achieved? So let's go through the code, and very quickly, I think some of you are gonna feel a little bored here, because it's how to say it, there's no demonstration, it's more like pure programming. So it's mainly code. So here I'm including a servo library that's being written, where you have the object servo that's gonna be used, and we need to create a servo. Here I define basically the pins. I assign them as global variables, and their numbers each correspond to a particular pin on the Arduino Nano board. And so how do I achieve the multitasking is by basically using time, keeping track of time. So the loop will go through the entire different tasks that we need to check for whatever state they are in, and basically whatever needs to be updated, we have to update it with respect to their timing. And so for that we needed to track time, and millis is a function that basically runs like a clock, like a watch. So it keeps track of time as it progresses. And depending the amount of time that we want to spend on a certain task, while we're in the loop, we don't hold the tasks that come after it. Instead, we just check for a particular task how much time is needed to be executed in that, and then we go on to do another task. And as soon as we verify that the timing is up, then we basically do the update for the status for that particular task. So the setup function, we have basically to define the pins in which mode they are going to be in. So we have the LED and the servo pins are going to be as output, the digital pins. And then the servo, we attach it to the servo pin. And what else? Yes, and then we define basically a servo control method or a function where we control the servo by reading basically the potentiometer level. And then we have the previous melody that we discussed previously in the other videos of composing note, except that I had to update it so that it no longer holds, because if I use it as previously written, it will hold me, and basically this servo cannot do anything until this has finished everything that it needs to be doing inside this loop, because this loop keeps it's a wild loop that basically Arduino needs to run through. But if I basically unfree these from freezing the loop, then the servo can will have enough real-time response to the potentiometer. Every time we update in real time the potentiometer, and basically we will be running through this method and being able to update it to the new position. And so it's very simple, the servo control. So basically we have to read from the potentiometer pin, which we defined as analog 0 pin here. So we read from it the value, and basically the Atmega microcontroller has some digital, has some analog to digital converter that basically converts from 0 to 5 volt the values from 0 to 1023. And by getting that value from there, I can basically map the values of the potentiometer to the angles. So I have two ranges. The first range is from the potentiometer values, the numerical values, from the digital to analog, from the analog to digital converter, and then we convert it to the range of 0 to 180 degrees. Then we basically we use the method right in the servo object, servo1 object or instance of the servo object. We write the angle, and that will put the servo to that position. Now, what I've done to multitask the melody is as following. As the melody is composed of a atomic function here, play note, and it depending on the note is the frequency. So here I play different notes. So I had to basically keep track of two things: the time that's been spent running a note, say note 1, and 2 is also making sure that if I am running note 1, I will not run note 2 or 3 or 4, all the other, and that is by using a note sequence with a switch a statement and cases in default. Basically I will keep track of on which note I am on until that note has finished playing, because the code will run through the entire thing as it loops fast. And so we go to the atomic play note and see what I actually updated in that. In the play note here, I basically added a few things. So I added a flag tone, which keeps track of whether the buzzer is on or off, because the buzzer needs to be on for a certain amount of delay of time, dt, 100 millisecond. Then it goes off for that same amount. So I basically use the current time and previous time to compare it. Using the millis, I update the current time while I'm running through the entire loop, and then I get the previous time and compare it. So if this is not true, if basically the difference of time is still not true, then this loop is false and we cannot go inside it. So first, the flag tone will be off, will be false. which means this is true. However, we need to spend this amount of time before we get inside. So because, let's say first, basically there is no buzzer. That initial time until we spend 100 milliseconds, we cannot execute any of this. So the code will run through this, but will not execute anything because of these if conditions. As soon as we basically pass that delta t and this flag is on, then basically we turn on the buzzer. We now turn on the flag to true, and that means this loop will no longer be, we will no longer be able to go inside this loop anymore. And then we basically, here is just to play, this is a lambda expression to basically play with the LEDs. So if the note frequency is less than 300, basically put LED 1, which is green, to on, otherwise put yellow LED 2 to on if note is higher than 300 Hertz. Then this is actually detail that not part of the multitasking. This is what we need to do in the play note. But the multitasking is basically by comparing the times and having these flags. And then now suppose once we basically have this is on now, the buzzer is on, so basically the previous time gets updated to the current time of now that actually passed that t. And now we go and this becomes false because of the flag becomes true, so this will never be on until the flag changes value to false. And basically leaves us to only this condition, in which basically we have to run, this will be true, but we need to also run 100 milliseconds before we can actually be able to go inside this loop. And so when we get inside this loop, once the time while the buzzer is on has finished of delta t, which is 100 milliseconds, we then turn off the buzzer, so no more buzzer here, and we put the flag to false, which makes us no longer getting inside this loop in this condition statement. And then what remains is going to be here, but we have to also pass certain amount of dt time before we can get inside this, and it keeps repeating. However, what's different in this one is we have note sequence. We keep track of note sequence because we have different basically we have different how to say it, so basically we keep track of note sequence here by once we have basically turned on and then off, we then update the note sequence, and now we can basically go and play a new note. We have already spent basically we have played this note. Then once this updates, we go to the switch statement, and the switch statement, this note sequence becomes 1, which means this note, first note 1, has already played. No, we can never get inside this one. So now we play this atomic play note function. With that said, basically let's go and upload it and see what happens now here. So we're gonna upload it. And so now I can basically play with the potentiometer and see that not only I am able to play music and play with the LEDs, but also I can actually control in real time a servo motor with this tiny chip. This is As you can compare it to my finger, is as small as my finger, is able to do all of this, and it can actually do more. This is not even half what it can do.